My dear student, you see the next question is question number 4 in the miscellaneous exercise, where the function is given. We need to find out the domain and range of this real function. So f is a real function from set R to R, that is a real function given by if f of x is equal to root under x minus 1. We need to find out the domain and range. So to define the function, f of x, what should be there? Within the square root, whatever the term is there, it should not be less than 0. So it should be greater than equal to 0. X minus 1 greater than equal to 0. So can we write, using the inequality concept, x is greater than equal to 1? Means all values of x is permissible which are more than or equal to 1. So we can write domain of this function f should be equal to the all values of as a real number 1, starting from 1 all rest values as a real number, and excluding, I am using here infinity, that means till the largest possible number it is possible, starting from 1 equal to 1 more than 1. It may be 1.5, it may be 1.6, it may be 1.7, it may be 2, it may be 2.5, it may be 3, it may be 3.5. So any possible real values. Now how to find the range? See, to find the range of this function f, what we need to do? To find range of f, we have to process something. What is that? Let this function first of all, let y is equal to f of x. Can you write it y is equal to root under x minus 1? On squaring both sides, can I write y square is equal to x minus 1? We can write it on squaring both sides. On squaring both the sides, we are getting this y square is equal to x minus 1. Now x in terms of y, it should be y square plus 1. Now see, x is dependent upon y. So to find domain, if we let this f of x as y, to define f of x means to define y. So we need to find the values of x. To find range, we do the different process. Already we know the codomain. Codomain is here R. So to find the range, the values of y for which x is defined will be the range. So here you see y square can't be negative, because if you are taking it minus 1, it will be minus 1 plus 1, that will be 0. So what we can write here, to define x, y square should not be equal to minus 1. Means y square can't be minus 1. So what it can be, but y square can be 0. Means all real numbers are possible including 0 and rest. So what we can write, therefore required range of the function f, it is equal to the all values starting from 0 and rest all values. I am putting the infinity and excluded sign. That means starting from 0 we can take any value. See, if it is 0, x is 1. If it is 1, it is 2. If it is 1.5 or 1.5, if it is 2, and we are getting always a real number. So that is our condition. We should get a real number. But if less than 0 we will take, it will disturb our definition of domain of the function. So this is all about domain of the function, and this is range of the function. Next question I am going to discuss. Now see everyone, next question number 5 from the same miscellaneous exercise for chapter 2. Question number 5. Find the domain and range of the real function f defined by f of x is equal to modulus of x minus 1. Real function x, real function f, that means f is a function from R to R given by f of x is equal to modulus of x minus 1. As earlier I have told you about this modulus function. Whenever we are talking about modulus function, do remember that its domain should be the set of real numbers and its range will be always positive real numbers. So how will you explain? How will you extend it? It will be x minus 1 if x is greater than equal to 1. It will be minus x minus 1 if x is greater than less than 1. So either it is x greater than 1 or less than 1. Function is defined. We are getting different values, but function is defined. Here we have to check for which values function is not defined. So can we think it will give us always positive values? If it is less than 1, it will be negative, so minus sign is already multiplied so that it can be positive. So for whatever the values we will put for x, we will get always the positive value for f of x. Means the range will be the positive real numbers simply. So we can see here for any, we need to find out domain and range both. For any value of x belongs to R, f of x is defined. F of x is defined. Therefore, domain of this function f will be R. And then what will be the range here? For each x belongs to R, we are getting f of x belongs to R plus positive real number we are getting always. So that's why, therefore, range of this function f will be set of positive real numbers. So this is the domain and this is the range. We can check it also while taking some values. We can find that it is true. Just see from the arrow diagram, you can see. Just taking here R, here also R. I am taking some negative and positive values. Now see, minus 1, 0, 1. Now see, putting the value x is equal to minus 1, it will be minus 1, minus 1, minus 2. So, but here whenever x is less than 1, it will be minus x minus 1. So it will be minus 1, minus 1, minus 2 and minus plus 2. So if it is minus 1, it will be 2. And if it is 1, let us see, if it is 1. So if it is 1, we are getting x is equal to 1. Then 1 minus 1. Just check it. 1 minus 1 will be 0. So it will be, if it is 1, it will be 0. Now you see, putting minus 1 also doesn't give you the value negative. That means we are going to have always positive values. So that is my concept here, range of the function.